Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 Certification Exam Preparation course, and we are now ready to dive into Lab 3.5.7, and this is definitely going to take us into the deeper end of the Python programming pool for the course. And here we're focused on creating a Python unit test. This video is going to focus on part 2. So what are you going to learn in this video? We're going to go ahead and we're going to learn about Python's built-in unit test module or library of functions that we can use. We're going to create some simple examples to lay the foundation for the more complex testing scenarios that you're going to see in this lab. And I'm going to explain to you or answer the 2 questions that you find at the beginning of the lab, in addition to a line that you're going to start to see often, which is the if dunder name equal dunder main, and why that line might become important. All right, well, first things first, let's talk about the answers to the 2 questions at the beginning of the lab before we dive into some specific examples. So, how does the test runner know which methods are a test? Now, you would have picked this up from the reading of Module 3, and we know that a method which is linked to a class has a def statement just like a function does. In fact, let's take a look at an example of what that might look like here in an example we're going to see in a minute where we're using unit test. Well, here is a class that I've defined inside this file, and here is a method right now. Again, it looks just like a function, but it's tied to the class. It's tied to the class. So def test underscore divide underscore by underscore 0. Now, that name right there, test underscore divide by 0, as long as this begins with test, we are in great shape because that is how the test runner knows which methods are actually test methods. That I'm going to say, hey, I want you to try to divide by 0. I want to check to make sure that an error, 0 division error, gets raised. And that's sort of the test that we're going to be doing here with unit test. Now, the next question, which might have been a little bit more difficult, but again, findable in Module 3, was asking you from the command line, how would you get a list of all of the command line options for unit test? Well, let's pop out of the Python Interactive Interpreter here, and I could simply say, and they give you some of the examples down below, so I would say Python 3 -m unit test, right? And this is if I was calling it from the command line, we could just go with our trusty -h. And as you can see, that is going to produce all of the output for all of the different options in order to run our unit test from the CLI. Now, this is the approach, this Python 3 -m unit test and then the name of the module. This is the approach that you would use if you're not using the line that you see, or I should say the 2 lines in this file anyway, that you see right down here at the bottom. So what is this and why do we see this? Well, you're seeing this, and this is a very common Python convention. The main, or I should say, name these attributes here, name and main. So name is an attribute, and we're checking to see if the name attribute is equal to the string dunder main. And so why are we checking that? Well, if we run the program directly, like if I come up here and I say run and run without debugging, this would be equivalent to running the program on the CLI with a command like let's say Python 3 and then, my test file .py. Now you'll notice there's no -m in there, right? And that's the difference. If you want to run it like this, being able to say from the CLI, Python 3, and then the name of the file, you have to have these 2 lines at the end of that file. Now, if you're okay with leaving these two lines out, that is where you would do the following, something like this, right? Like Python 3 minus m unit test, and then the name runs the test from the test module. And this is the way you would do it if you don't have these two lines at the end. So again, I'm keeping these two lines at the end because we're doing everything in VS Code. This is going to be much easier to do with those two lines in there. But again, this is just a convention that's checking to see, hey, this attribute name, is it equal to the string dunder main? And you can see what I'm doing right here is I'm actually going to print this up for you to show you when we run the program directly, what is the value of the attribute name? And it's just simply going to be main, right? Because main, and here's what I want you to think of. The reason we say unittest.main, open parent, close parents, is that the main function, right? I'm sorry, the main method here is going to be all of the code that you see right there. So what do? We check to see if the attribute name produces the string dunder main. If it does, if this is true, and it will be because we're running it directly like we were saying, Python 3 space file name, unittest.main, so we're going to have our unit test run, and it's going to run the main function. You can see right here, it's primarily for making test modules conveniently executed, right? This main method tells this program, hey, run the code that's up here, right? And that's exactly what we're going to have happen. So let's run the code and let's see what happens. And then we'll talk about this class that we created here and some of the things that you see in here. Again, this is a very simple example. I've got another very simple example where we're going to break things into two files, because as you can see, unit test all in one file. This is not something that's very common, right? Typically, you've got your modules and they're packed with all of your code that's going to be running. The unit testing is typically compiled, or I shouldn't say compiled is not a good choice of words, is all collected up into a testing module like test_calculator to test our calculator functions that we have. But let's run this and see what happens. So we say run without debugging. And if I was to give us a little more real estate here to see what just happened, you can see there we go. So it runs this file, and the value of name is what? There it is. It's the string dunder main. Therefore, it is going to run, and the dot here, that's just telling you, hey, I ran one test, which it then tells you again down here, ran one test, it was in 0 seconds, and it was okay. In other words, the test that we ran here came back as, whoops, and I apologize there, I didn't want to drag that much down. That test that we run here, that we define the method test_divide_by_0, it runs, and we're checking to see if I divide 10 by 0, right? Does it raise a 0 division error? And here's this assert raises. And you can take a look. It says fail unless an exception of class, expected exception, which is 0 division error, is raised by the callable when invoked with specified positional and keyword arguments. And so we're checking to see with self.assert raises 0 division error, when I divide 10 by 0, what happens? Do I get the 0 division error? If I do, my test succeeded. It's okay. If I don't get the 0 division error, then I would get a failure. So what if we changed 0 division error to name error? And you can see that's another sort of built-in error that can be raised. Well, are we going to get a name error for dividing by 0? No, we would get the exception that would be raised would be the 0 division error. But let's see what happens if we run this, right? Let's go ahead and save our file here. Whoops. Save our file, and then let's say run without debugging. And what do we see? Now, instead of a dot up here, whoops, you can see that we get error test divided by 0, so we get an error. Now, the value of name, it's still main, right, because we're executing this file directly, and so that attribute dunder name will be main. When you don't execute it directly, you might be wondering, okay, well, if I don't execute this directly, what is that attribute? And that's it'll actually be the name of the module. So you see, we get this error, test divide by 0, right? We're checking for a name error, but we're going to get a 0 division error, not a name error. And you can see failed, so we have an error here. And so that's just to show you, again, a simple example of what we would call a unit test. And so we'll say 0 division error. And so this is a unit test. And so really, what am I testing? I'm testing to see that if I divide by 0, is it going to raise a 0 division error like I expect it would? And it does. Okay, let's talk about some of the other things that we see here. Specifically, this class name that I'm creating, that is my convention, right? So we created classes back in lab 346, so this should look familiar. However, what might not look familiar is this right here, because what we had was class test : we didn't have these open parent, closed parents with something in here, right? So what is this doing? Well, what I'm doing here, remember, unit test is a library of features and functionality. And I'm basically subclassing, right? I'm creating a subclass called test division, and I'm inheriting, or you can think of it as borrowing. I'm pulling in all of the unit test test case class features and functionalities, right? So I'm basically, you can think of it as, I'm just importing, right? I'm pulling in unittest.TestCase and all of its features and functionality. Well, what are all the features and functionalities of this test case class? Well, let's step over to the documentation. So if you were to Google unit testing framework Python, chances are you're going to come up with this. So if you're already familiar with the basic concepts of testing, you might want to skip to the list of assert methods. Well, we saw over here, what am I doing? Assert raises, right? Okay, well, what other things could I do here? Well, let's click on that. So you can see that here are some of the other things you could do. Assert equal, assert not equal, assert true, false, right? So you can check to see if something's equal. You can check and see if things aren't equal. And again, these are all test things. These are things you would be testing for. And you can see right here, the test case class provides several assert methods to check for and report on failures. Well, if I click on test case right here, this takes me to the test case class. And here it is. So the class is unittest.TestCase, and we would put a method name and then run the test. And instances of the test case class represent the logical test units in the unit test universe, right? So again, we saw some of the different asserts that we could do, things that we could check for. If I was to go all the way back to the beginning here and I wanted to come right down here, you can see, like, here's a basic example. And again, here's that convention that you see. If dunder name equals dunder main, then, hey, just let's run the code that's in this file. So what do? We import unit test. We create a class called test string methods, and we inherit, right, from the parent class unittest.TestCase, assert equal, assert true, assert false. And so when I say self, right, you see the self again, it's referring to my class here, right? That's what self is referring to here, is my class dot assert equal, because my class is inheriting all these cool things from unittest.TestCase, like assert equal, like assert true. And so this is just kind of shorthand for me to say, yeah, my class test strings method, and I'm using all of the stuff that's in unittest.TestCase, the unittest.TestCase class. So now I just have to say, okay, self, and self refers to all of that. And in all of that, I have access to assert equal. I have access to assert true, to assert false. We just saw those in that table we looked at earlier. And so that's really all we're doing in these lines of code, or this line of code right here, I'm defining my method that's going to check to test divide by 0, right? And that's my test, and that's how the test runner knows that this method is a test method. And then with, you can think of it as like with open, right? I'm just basically saying, okay, so with this assertion raising a 0 division error, and keeping this in mind, right? Is that test right there going to raise a 0 division error? Now, what if I was to do the following? What if I change this test to be, 81 divided by 9 will do, because 9 times 9 is 81. I remember that was one of the first multiplication things that I knew, that I memorized, was 9 times 9 is 81. So let's see, is that going to raise a 0 division error? Well, we know that it's not, because we're not dividing by 0. The denominator is 9. So what is it going to do if we do that? Well, let's click Save. Let's click Run. Run without debugging. And what do we get? Yeah, so now we don't get an error per se. We get something different. And let me pull back up here. Whoops, and did I go too far there? Oh, I didn't. Okay, sorry. So we get that error, but it comes back and it tells you, hey, the test failed. We get a type error, missing one required positional argument, y. But what's happening here is we're not dividing by 0. We're checking to see, is this going to raise the 0 division error? And it doesn't, because we're dividing 81 by 9. We should get 9, so it fails. But if we were to change it back to 81 divided by 0, anything divided by 0, we're going to get the 0 division error, and this test is going to succeed. And we'll say run without debugging. And there we go. And the test is okay. It did what we wanted it to do. So now let's take the next progression, the next step in our unit testing, because we wouldn't typically do all of this in one file. Here we did, just to kind of start to lay the foundation for what it is we want to do over here and later on in this lab. So here's my calculator program. Again, this is just a Python module that has 4 functions in it, and the functions are add, subtract, multiply, and divide. Now you can see, what did I do down here? Well, down here, I'm basically doing a quick check inside the function that if the denominator is equal to 0, I am going to raise a value error with that message, right? And raise value error is basically saying, hey, I'm raising a red flag here. Whoop, whoop. We've got a value error. You cannot divide by 0, right? So if the denominator is 0, I raise an error. Otherwise, I'm going to return x divided by y. Now, we're going to make it a little bit easier, because again, this is how you would work around, well, what if they pass in 0 as the denominator? Well, this is how I would handle that, right? Inappropriate argument value. So we're going to take a look at doing the add function here. But we need to come over here. Remember, you don't see any testing unit test stuff here, right? Because again, think of this as like, well, this is my main program where I've got all my cool code and I'm going to be doing super cool mathematical functions. Now I want to create a mutually exclusive independent file in which I'm going to define my testing. And here's what that would look like. Now, this should look very familiar. In fact, I can go ahead and we'll print out the value of dunder name as, is dunder name. Sorry, I was like, why doesn't it say main there? And I was like, okay. So, but again, we're going to print that out just so that we can see, hey, if I run this file directly, in other words, instead of running Python 3-m unit test and the name of the test module, if I just want to run it by typing in Python 3 test_calc.py, these are the 2 lines of code I need to have. So again, we import unit test, right? We're going to import that framework, and you get some information right here about the framework. But I'm also importing something else. I'm importing calc. Now, this is the first time we've seen something like this, and so I want to explain this. You might be saying, wait a minute, where in the hell what is the calc module? Why are you importing that? Well, remember, the calc module is the Python module we created right here with these 4 functions. So in the test file, I import the module that has the functions I want to run testing on, because I want to run a series of tests to check to see, do those functions produce the output that I expect them to produce? So I import it. Now, once I import it, you can take a look. I can say calc.add, because in the calc module is the function add. So I import that calc module that I created into my testing file. And here I can then simply run tests. Calc.add, calc.subtract, calc.divide, right? Multiply. So I could test all of those things here. But for the purposes of this, we're simply seeing this single example here. So again, that test calculator class name, I created that. I could have called it test calc if I wanted to. So I create a class, and then I inherit, right? I borrow all of the features and functionality from unittest.TestCase. And again, if you hover over these things, take the time to read these. And if I come here, you can actually scroll down, right? And there's a little bit more to be read. I hover over test case, and then I can see that, oh yeah, we'll take a look at that. It gives me some additional information, right? So I'm authoring my own test case, and I'm creating my own class to do that. And then I'm just telling Python, hey, I want to borrow all of the features and functionality out of this other class that you've got, this library of function, or the library of features and functionality. And I'm going to pull that into my program here. So then how does the test runner know that this method called test_add is a test? It starts with test, right? Simple as that. So here's my method. And what am I doing here? Self.assert equal. Where have we seen that before? Well, we saw it over here in the documentation when we looked at that example there, but it also occurred here, the assert methods, assert equal. And so when I say assert equal A, comma B, and these are just placeholders, right? A, comma B are placeholders. I could have like 5, comma 52. So is 5 equal to 52? No, right? So we're checking to see if things are equal. And so here's my test. I want to check to see if I send my calculator function 2, comma 2. So 2 is X, 2 is Y, right? Does it give me 4? Is 2 plus 2 4? And if this test passes, then it's going to tell me, hey, we ran the test and everything looks good. So let's get rid of that. Let's go ahead and say File, Save, and let's run this module. Remember, it's importing those 4 functions out of my main program, calc.py. And so what happens? And you can see the value of dunder name is dunder main because we ran it directly. And we come down here, ran 1 test in 0 seconds. Again, it's kind of tough to scroll. And that, again, that period that you see there is just telling you, hey, I ran 1 test. Well, let's see what happens if I say 2 plus 2 equals 9, right? Assert equal, is that going to be a successful test, right? I'm sending these values into my function for X and Y, 2 and 2, and I'm saying, comma, does it equal 9? So let's test our calculator function to make sure that if it doesn't equal 4, 2 plus 2 doesn't equal 4, that we get an error of some kind, right? That the test is going to work. So we'll click Save, we'll click Run, and we'll run without debugging. And there you see not an error, a failure. And this is important, right? Because prior to this, we were seeing errors, right? Or it would say E for error. Here, and if I scroll back up ever so gently, we see the F. We don't see a period here. Remember, it was a dot before, telling me, hey, you just ran 1 test and everything was cool. If it fails, right, and this is how I would test my code. Maybe we're sitting together as a group of programmers, and now I say, hey, okay, whoa. We have a problem here. Because if I send 2 plus 2 in there, it should equal 9. And our test failed. So now we can go back, we can take a look at the calc program, and we can see, okay, when I sent 2 plus 2 in here, what was going on? What was wrong? So this kind of helps me, this test case, right? This test-driven development that I'm doing is I'm looking at this and seeing, okay, do my functions do what they should do? Am I getting the results that I should get? And here, if I was expecting to get 9, when I put 2 plus 2 in there, I can see that, hey, I've got an error, that 4 does not equal 9, because 2 plus 2 is 4. Ran one test, it took 0.001 seconds. You see how quickly that ran? And it was a failure, right? And again, the key here is we're doing this in 2 separate files. Could I do all of this in the same file? Absolutely, but that's typically not how it's done. For small, little, simple examples like this, yeah, you could get away with it. But once you start coding and you've got a lot of code in your files, as you're going to see as we get into Lab 357, we've got some more complicated examples that we're going to be taking a look at. You would not keep it all in one file. You would have your code in one file, right? Your main program and whatever it is you're doing. And then you would create an individual unit testing file. And that is how you would approach things. Again, this if dunder name equal dunder main is in here because we're running it directly. So watch what happens if I do this. Let's comment those lines out. Let's save the file. And this is important to understand the difference here, the semantics between running it with those 2 lines and running it without. When I run it without, did unit test run the main method, which is all of the code that's up here? No, it ran the print statement. It didn't come up here and run this test calculator unit test case. It didn't do this, right? That is really, at the end of the day, what this unit test.main is running. And this shows us that that's the case because it ran the print statement, right? It ran the print statement, but it didn't run the class that is inheriting from unittest.TestCase. And this little, I don't want to call it a shortcut mnemonic or whatever, but this convention right here, this unittest.main says, run my test class. That's what's happening there. And you can see without it, it doesn't. But let's do this. Let's save this. Let's just make sure it's saved. Let's go out to the CLI and actually let me do file save as. I want to confirm where this is at. And yeah, I think this is all the way down in the bin netacad tutorials postman directory. So let me click cancel here. And you can see that we're in bin netacad tutorials postman. I'm on the CLI right here. So what happens if I say Python, test_calc.py? Again, it comes up and says Python, oh, I'm sorry, I'm on Python 3, my bad. Because it should come up and do the same thing it did as when we ran it. And there you go. And that's what it does, right? It comes up and says the value of dunder name is main. But it didn't do all this cool stuff. So how do we get it to do that? Remember, from here, right, if we're doing the unit test, the test_module, is that what we would do? Oops, sorry. Is that what we would do? Well, let's give it a try. Let's type in Python 3 -m unit test. And then what's the name of our file? test_calc.py. Ah, so that does what we need it to do. And that is the difference. If you've got these 2 lines in the file, and they're not commented out like I have them here, if those 2 lines are in your file, at the end of the file, then you can simply type in Python 3 and the name of the file. If those 2 lines are not at the end of the file that you're using for testing, you're going to have to do, and you're doing it from the CLI, you're going to have to do this. Since we were doing all of this in VS Code, we want these 2 lines in there, and it's not a bad thing to understand or to get used to typing those lines because they come in handy in other instances as well. All right, so we've laid the foundation now for what unit testing is all about. We saw where the documentation is at. We saw what unit testing would look like with everything in a single file. Again, not very common. And then we split things into multiple files where we had our code file and then we had our testing file. And that is a great segue into part 3 of Lab 357, because that is exactly what we are now going to be dealing with. We're going to be dealing with a recursive JSON search, which is a script that includes the JSON_search function that we want to test. And then we're going to have a test_data.py file. We're going to have a test_JSON_search file as well. And we're going to be running more complicated, complex testing with those files. But now that we understand how unit test works and what things should look like, we can dive into more complex examples. All right, well, that does it for part 2 of Lab 357. We're now ready to dive into part 3. Thank you guys so much for watching, and as always, I hope to see you in the next video.